Welcome to a new video on the use of the ConceptBase system. The topic of today is how to define simple integrity constraints and rules for the ConceptBase system. My name is Manfred Josfeld, and we are using the example that is available on the web. The link will be in the description of this video. So it's a classical employee example. We define some classes here, copy and paste that to the TLOS editor, to the text view here. So employee has name, salary, department. Employee also shall have a boss. Departments have a head, and the head must be a manager. Well, and the manager is a subclass of employee. So let's tell that. We can also visualize that in the graph browser or graph editor. Let's make it a bit bigger. I'll show the connection, and yeah, a bit nicer here. Don't want to see class. Let's keep that here. So that's definition of the classes that we saw. Now let's iconize this and go to a script that is on this site here about defining rules and constraints. So far we have defined just the schema of our employee database. Let's empty this text window and define a so-called deductive rule, the boss rule. So remember that we defined the boss relationship at employee. That's going to be derived from the department of the employee and the head of the department. So we may not have to enter the boss relation manually. It is derived from these other relations, department and head, debt and head. So let's tell that then. So note that deductive rules have here this predicate that they derive, that the derived predicate, and that depends on a predicate in the conditions. We have some variables that are declared here. Variables are assigned to classes, so they range over classes. So E ranges over employee. So all the possible values for the E variable are made up of the instances of employee. This finite set of instances. So let's empty this window again. That doesn't mean it's deleted, it's just to have some space. Let's define an integrity constraint. So employees should earn less than their bosses. So if E has boss B and X is the salary of E and Y is the salary of the boss, then X must be smaller equal than Y. So we tell that it's currently fulfilled. We have no data currently in the database. So let's add some data. Again, in this file here, we had defined until department. So let's define these employees with German names. So production is a production department, Vertrieb is sales, Verwaltung, administration, Forschung means research, and so forth. We have some salaries, and later we will see that some employees also have departments. So I press the tell button. Now it's told. It's indicated by this color. Let's go back to our script. So to define some, that was a wrong click. Let's define some more constraints. So that is a constraint on manager. The salary of the manager must be greater than 50,000. Maybe a business rule. Now when we tell that, we get a violation here. Eleonora is earning 20,000, and that's not enough. So when we copy the name here, we can load, and we see here Eleonora only earns 20,000, so let's give Eleonora a salary increase. We do so by updating the properties that we want to have updated, and that's only the salary. And the update here is called retell. So we have the old value and the new value. In this window, let's give it 55,000 like in the script here. That is accepted. So now we see the full definition. Eleonora is in manager, salary is 50,000. So let's see whether our constraint goes through now. Yeah, so we can't define constraints after the database is already filled. We can also add classes, and we can update classes. As long as integrity constraints are not violated, this is allowed. So let's go to the next constraint, that is necessary salary. We have two alternatives. I take the simpler one. So all employees must have a salary. That is the condition here, and that is acceptable. And next is similar, all employees shall have a boss. Let's tell that, and that is violated. Actually, let's see what the definition of Hubert is. So Hubert is a manager. So not all employees must have a boss. We have an exception for managers. So rather than changing the database, we change the constraint. So we have another condition here, or E is in manager. So we relax these rules for those employees who are actually managers. Note that manager is a subclass of employee. Each instance of manager is also an instance of employee. So let's tell that, and this is now accepted. So we had so far one rule and a couple of integrity constraints. The next rule is a bit peculiar. So it has no variables. It says when Eleonora is not the head of Verwaltung, administration, then Eleonora is the head of production. So that is a rule where the condition is negated. And so if we assume that Eleonora is the head of Verwaltung, then she will not be the head of production. But if we then delete the fact that Eleonore is the head of Verwaltung, then she will become the head of production. Let's tell that, and let's see the definition of Verwaltung. Indeed, the head is currently Eleonore. So she is not the head of production by this rule, because this is not true. The next two constraints are odd cases, so not very interesting. Next one is that we must have at least one manager. That's an example of a constraint that has no universally quantified variable, only existentially quantified variables. So there exists at least one manager. So the class manager is not empty. That is currently true, so we can tell this constraint. Next is another rule that defines a subordinate relation between manager and employee, and that's just the inverse of the boss relation. The boss relation is from employee to manager, and subordinate is from manager to employee. So this is the inverse relation of the boss relation. Let's tell that. So rules should normally go through. Next constraint is a bit an interesting constraint again about Eleonore. So if Eleonore is ahead of production, then the salary must be greater or equal 100,000. All attributes and relationships are by default multi-valued, so we demand here that all the salaries, bonus salaries, regular salaries, must be greater than 100,000 here. That is acceptable because she is not the head of production yet. So we could explicitly make her the head of production, but we could also untell or delete the fact that Eleonore is the head of Verwaltung. So that's the untell operation here, and that is not allowed. So that violates a constraint here, and in this case each the concerned constraint is each employee must have at least one manager. So this is violated because the previous constraint was defined on manager or employee. Let's see. That is the summary of our definitions for employee constraints and rules so far. So necessary boss is triggered here. Let's untell this. So we can also remove a constraint at any time. So we just leave that was a constraint, so I have to say that this is a constraint. And let's untell this. Oh, that's not accepted, so let's forget about that. Anyway, let's continue here. I skip some of the constraint here and define the transitive closure of the boss relation. So big boss shall be the transitive closure. It's either if we have a direct boss or we have a boss in the middle and then the transitive closure over this relation big boss. Then we have a constraint that nobody can be transitively boss of him or herself. That's currently acceptable. Let's make Eleonora an employee of Verwaltung, then she's herself the head of the department Verwaltung. So if we make her also the department, then she will be the boss of herself and then also the big boss of herself. So let's tell that, and that's indeed here the clash with this no big boss of self rule of manager. Let's see what we have defined so far with manager. So these are some rules and also some constraints. So the constraints and rules are attached to those classes where we define them, and we define them either for employee or for manager. That doesn't make a big difference. Yeah, so that's almost all. Let's go back to the graphical view here. So we can also show the constraint here. And also some rules. Let's see. This one I think is a rule. For the manager we also have some like this one here, the inverse rule of the boss rule. Yeah, you can display the instances here. So these are the instances of manager. I don't show more, but with that I conclude. So the link to the source code is in the description of the video, and yeah, you find a so-called graph file there that will contain most of the definitions that we talked about, and you can just load it by clicking on that if you have installed ConceptBase on your computer. Thank you for your attention, and bye-bye.